Hello dear aspirants, welcome to Dr. Sourav's classes, and in this video I am solving CMI M.Sc Math, that means Chennai Mathematical Institute का जो पोस्ट ग्रेजुएट का प्रोग्राम का जो मैथमेटिक्स पेपर है उसी पेपर का MSc और PhD के लिए जो एंट्रेंस है उसी एग्जामिनेशन का रिसेंट पास्ट पेपर सॉल्यूशन 2024 का. If you want to take classes from our side or want to take doubt clearing session, previous year question solution, mock test, study material, any of that, please don't hesitate. Please call or WhatsApp on this number. Dr. Sourav himself reply to your query individually through WhatsApp. So already all you all know that Dr. Sourav's class is the best coaching institution for any type of mathematics related examination. So if you want to take admission from our side, this is the best time. Why? Because now we can provide maximum discount of that course. So don't waste time. This is the best time to take admission in Dr. Sourav's classes and boost up your preparation with Dr. Sourav sir. So let's start with question number 8. What will say this question 8? Which of the following statements are true? There are some statement related question. Every prime ideal of finite commutative ring with unity is maximum. A commutative ring with its unity whose all ideals countability infinite is necessarily a countable ring. And option C, let R be a unique factorization domain and K be its field of factorization, then there exists a irreducible element, that is alpha belongs to R and an element beta belongs to K, such that beta square equals to alpha. And every sum ring R with unity of Q with Z subset subset not equals to R and subset not equals to Q. So what will be the correct options for question? Let's check how we can check option A. So A most probably the will be the correct option. Now let's see the explanation for that option. So first concept is that prime ideal. So prime ideal means that can be Pi. So in a commutative ring R, in that ideal P is prime whenever AB P is prime whenever AB belongs to P, and it follows that either A belongs to P or B belongs to P. So maximum ideal is here. So an ideal M of ring R is maximum. An ideal M of a ring R is maximum if it's proper. That means here M not equals to R, and as there is no ideals I such that M subset of I is a proper subset of R, where I is strictly larger than M. So now finite commutative ring, a ring with finite number of elements with commutative, that is multiplication is commutative, has a unity and multiplicative identity also. And this statement is every prime ideal for a prime commutative ring with also a maximum ideal. So now we can explain in detail. So first we can talk about finite commutative rings. So here in a finite commutative ring, we know that the ring has finite number of elements. A key fact about such rings, sub number of ideals is also finite. And moreover, in a finite commutative ring, every prime ideal is what? Maximal. Okay, so this is because the following reasons: Zone's lemma and ideal properties. Zone's lemma and ideal properties. In general ring theory, a maximum ideal M in commutative ring R corresponding to the fact that R by M is a field and a prime ideal, a prime ideal P in R gives that R by P is a domain, a ring without zero divisors. And now we can check the third case. The special case for finite rings is R is finite. The R by P is a quotient by ring. Prime ideal is a finite domain also. And but in a finite domain, every non-zero element has multiplicative inverse. This is because in a finite set, the cancellation law implies the multiplication must from a group structure. Therefore, the finite domains is also automatically a field. Okay, and since R by P is a field, must be maximum ideal. Maximal ideal, because the maximal ideals are exactly those for which quotient is ring is filled. So therefore, for those reasons, which option is correct here? Conception correct hoga. Option A will be the correct option for that question. So that's all about that. If you like this video, share this video to your friends and your family. For latest video updates, please subscribe our channel and don't forget to click on the bell icon also. So, and that's all about that. We will meet you in next session soon. Thank you.